In a database that contains millions of rows, how do you go about uniquely identifying exactly one of them? How do you link the tables without losing data? These are key questions, and ironically, that's what keys are for. And there are 5 types of keys that you need to know within databases. Without keys, databases can guarantee uniqueness. You'd update the wrong row, delete the wrong record, join the wrong data, and commit other errors within the data that you're dealing with. Keys are the backbones of relational integrity for databases, meaning that it enforces identity, relationships, and constraints across every table within your relational schema in your database. The first type of key is called the primary key, which uniquely identifies every row in a table. It has no duplicates, no nulls ever. Every table should have exactly one primary key. It can be a single column like user ID, for example, or multiple columns combined. The database automatically indexes the primary key for looking up data quickly. For example, let's say we create a table called users and it has a primary key called ID, which contains integer values, and then a name attribute that is a string. Every other key type is defined relative towards the primary key. The second type of key is called a foreign key. A foreign key is a column in one table that references the primary key of another table. For example, it's how relationships between tables are enforced. One instance could be we alter an existing table called orders and we add a foreign key called customer ID, which references the ID column from the customer's table. We could try to insert an order for a customer that doesn't exist, and in this case, the database would reject it thanks to the introduction of the foreign key. Foreign keys prevent records to be orphaned, which means data that references something that no longer exists. The next type of keys are called first candidate keys. A candidate key is any column or a set of columns that could serve as a primary key for a table. It's unique, not null, and fully qualified. A table can have multiple candidate keys. You can pick one to be the primary key while the rest of them become alternate keys. A composite key combines 2 or more columns to form a unique identifier for the table, when no single column is able to be unique on its own. For example, if we have an enrollment table, neither student ID nor course ID is unique alone. However, if we join student ID and course ID together, they are unique. So we'd say primary key and then in parentheses student ID, course ID. Now a surrogate key is another type of key. It's an artificial identifier that usually tends to be an auto-incrementing integer or a UUID, and it has no real-world meaning. It exists purely to identify a row. The alternative is a natural key, meaning a real-world value like an email address or a social security number or some other identifier like that. Natural keys can seem convenient until they change. For instance, let's say someone goes about updating their email, or a company changes its tax ID, or your table joins happen to break. Surrogate keys will never change, which makes them the safer and more scalable choice for most database systems. So to wrap it all up, there are 6 key keys that we work with: primary, foreign, candidate, composite, surrogate, and natural keys. 6 keys that all have one purpose: keeping your data accurate, connected, and trustworthy.